Welcome back to The Explainer. So glad you're here. If you've been tracking the whole transition to electric vehicles, you already know it's frankly one of the most massive infrastructure shifts of our entire generation. But there is a giant, glaring bottleneck in the system. So today, we're going to dive into a genuinely fascinating solution. We're talking about bringing the power directly to the vehicle. We'll break down the cutting-edge research and the real-world data behind a totally decentralized approach to EV charging. Let's get right into it.
Let's kick things off with a feeling I'm willing to bet most of us can relate to. Have you ever experienced that creeping, sinking dread known as range anxiety? You know the feeling. You're driving an EV, the battery gauge is dropping fast into the red, and there is absolutely zero sign of a charging station anywhere. Or worse, maybe you finally find a station, only to pull up and see an endlessly long line of cars just waiting for a single working plug. It's rough, and it's a universal pain point that seriously threatens to pump the brakes on this entire electric vehicle transition.
To actually solve this, we kind of have to completely rethink our whole approach to infrastructure. Look at the stark contrast here. The current model relies heavily on fixed chargers. Now these are expensive, they're entirely grid-dependent, they require massive land acquisitions, and honestly, they are incredibly slow to build thanks to multi-year permit delays and intense civil construction. But on the flip side, we have this emerging alternative, mobile charging. This approach is agile, it's entirely off-grid, and is capable of immediate deployment. You don't wait for the grid to come to you. The power literally comes directly to your vehicle.
All right, here is our roadmap for today's explainer. We'll start with the infrastructure bottleneck, then look at the anatomy of a mobile charger, move on to the smart charging process, and wrap up with real-world fleet solutions.
So, part 1, the infrastructure bottleneck. Basically, grid expansion is seriously lagging behind.
We have to face the harsh reality here. Fixed electrical grid expansion simply cannot keep pace with the sheer rate of EV adoption. To really grasp the gravity of this, consider this quote from Nathan J. Mazurek, the CEO of Pioneer Power. He flat out states, "Enterprises simply cannot secure enough reliable power in an economically reasonable timeframe." Think about that. That is a high-stakes business reality. Major organizations, we're talking delivery fleets, school districts, utility companies, they are essentially desperate for alternative power solutions today. They have the electric vehicles ready to go, but they're just sitting idle because the grid is lagging years behind.
And that massive bottleneck? That brings us to the hero of our story, the Mobile Electric Charging Vehicle, or MECV. Basically, an MECV is a specially equipped, fully transportable charging station. It's specifically designed to deliver on-demand electric energy, whether that's AC or DC, to EVs literally anywhere. It's this incredibly powerful, almost magical tool that lets electric vehicle fleets completely bypass those massive utility delays and operational disruptions.
Moving on to part 2, anatomy of a mobile charger. Let's take a look inside the MECV. Let's conceptually pop the hood, so to speak, and check out the complex engineering that makes these vehicles tick. You see, an MECV isn't just some big battery tossed into the back of a van. No way. It is a highly intricate architecture built around 5 major subsystems. First up, you have the energy storage system, which holds the raw power. Second is the power conversion unit, which translates that power. Third is the charging interface. That's the physical connection to the EV. Fourth, the control and monitoring system, basically the brain of the whole operation. And finally, number 5, the vehicle platform and safety mechanisms, which keep everything totally secure and mobile. Now, what's really fascinating is how this physical layout actually comes together. Look at this cross-section. Down at the base, you've got the energy storage system, or ESS. These are typically your high-capacity lithium-ion or LFP battery modules, and they are securely mounted right into the vehicle's chassis. Why? Well, it maximizes energy density while keeping the vehicle's center of gravity nice and low for safe road transport. Then right above that, you've got the control system and the charging interface, all smartly integrated to deliver high-voltage power straight to that stranded or parked EV out back.
And here, we can actually trace the electrical backbone of the whole operation. If you follow the power flow, it goes from the energy infrastructure right into the mobile charging vehicle's battery. But the real magic happens in the middle. The power conversion unit, the PCU, uses a series of advanced DC-to-DC converters and inverters. It takes this massive amount of stored DC energy and regulates it into a perfectly stable, incredibly safe flow of precise voltage and current. Exactly what's required by the specific EV it's charging. It's essentially acting like a giant mobile high-tech transformer.
All right, part 3, the smart charging process. Let's talk about the intelligent software.
So we've seen the physical hardware, right? But what truly makes this a seamless, on-demand service is the intelligent software ecosystem running in the background. The pacing of this entire process is incredibly brisk. It's honestly a bit like a high-tech spy movie. First, a user makes a request via an app, and the MECV uses GPS to route itself to the exact location. Simple enough. But then, the moment the cable is actually plugged in, the MECV performs what's called a protocol handshake. Using the Internet of Things, it talks directly to the EV's battery management system to verify compatibility. Third, once everything is negotiated, it begins the regulated power delivery. And finally, if there is any anomaly, say a sudden spike in temperature, an automated safety disconnect instantly shuts the power off. Super safe, super smart.
Let's zoom out for a second to see how this all builds into a macro network. This service flow diagram maps out the whole relationship between the customers, the operators, and the mobile vehicles themselves. Fleet operators basically sit right in the middle, using central web-based dashboards. They take in these service requests and intelligently dispatch the MECVs. And they're using live traffic updates, plus predictive routing based on historical data to ensure these vehicles are positioned in high-demand areas before the calls even come in, which, as you can imagine, drastically minimizes wait times.
And finally, Part 4, Real-World Fleet Solutions. How this looks in commercial applications. Let's step back from the micro-level engineering for a minute and look at the commercial fleets that are actively solving grid problems right now. Check out this bold figure, $1.8 million. That represents the value of new 2026 orders secured by Pioneer Power for their off-grid EV charging solutions, and that was just in the first few weeks of the year. So this isn't just some conceptual research project anymore. Off-grid, mobile charging is a highly viable, commercially successful business model that is actively scaling across North America right this second. And that momentum, it is absolutely industry-wide. We are seeing millions of dollars flowing into this sector. For instance, there was a recent $1 million funding round specifically backing Spark Charge's off-grid EV charging hubs. The market is sending a really clear signal here. Waiting around for the traditional grid to catch up is just no longer an option for serious enterprises.
But beyond the financials, look at the actual human impact of this technology. There's a district in Central Florida, one of the top 10 largest public school districts in the US actually, and they acquired 26 brand new electric school buses for their fleet. Awesome, right? But then they hit a massive infrastructure delay. So to ensure 52,000 students could still get to school using zero-emission transport, they bypassed the grid entirely. They deployed Pioneer's eBoost fast charging units. And this brilliantly illustrates how the tech provides absolute operational certainty for mission-critical transport. No waiting for the power company to dig trenches.
So the crucial takeaway here is understanding these energy-at-the-edge realities. These mobile units are delivering incredible Level 3 fast charging. We're talking anywhere from 50 to 180 kilowatts, which means an EV can get an 80% charge in just 20 to 30 minutes. They require zero permits, absolutely no site construction, and no electrical upgrades. They're being used to support remote utility trucks and massive Canadian aviation hubs alike. And surprisingly, units like Pioneer's eBoost can even run on greener, renewable propane. This provides a clean pathway to net zero while instantly solving those massive power deficits.
Which leaves us with this final, kind of provocative thought to consider. We are completely changing the entire dynamic of how energy is distributed. So what does this all mean? If our fleets, our school buses, and our personal vehicles are increasingly going off-grid to find reliable power, is the future of the electrical grid truly mobile? It's a fascinating paradigm shift, right? Moving away from centralized power plants toward decentralized, on-demand energy. Well, thank you so much for joining me on this explainer. I really hope this deep dive gave you a structured, powerful new perspective on the whole electric vehicle revolution. Keep learning, and I'll see you next time.